Uh, a very good afternoon, everyone. Ladies and gentlemen, it gives me immense pleasure to welcome our next resource person for today's last session, Dr. Love Kumar. Dr. Love Kumar is currently working as assistant professor in the Department of Computer Science and Information System, BITS Pilani, Hyderabad campus. Prior to this, he was a faculty member at Thapar University. He received his PhD in Computer Science and Engineering from National Institute of Technology, Rourkela, under the supervision of Professor S.K. Rathod. His research interests include mining, software repository, machine learning, analysis, testing of artificial intelligence system, software analytics, and social media analysis. He has delivered over 40 invited talks and published about 70 publications in international conferences and journals with 2 book chapters. He has won several awards, including the Best Young Scientist Award, Best Researcher Award, and Best Paper Award. Sir, on behalf of Siksha O Anusandhan University, I welcome you to this FDP. It would be the matter of immense pleasure for all of us to hear from you, sir. We hope that all the participants will get benefited at the end of this talk. Now, I may please request you to deliver your talk. It's over to you, sir. Thank you.
Okay, thank you. So first I'm going to share my screen.
Yes, sir.
Just one second. Yeah, can you please check my screen is visible or not?
Yes, sir. Your screen is visible, sir.
Okay, fine. Yeah, my screen is visible.
Yes, sir.
Okay, fine. Thank you. Yeah.
Thank you, sir.
Yeah, so good evening, everyone. So in this session, basically, we will focus on feature selection techniques. Okay, and what is the importance of feature selection technique for artificial intelligence? So in this session, mainly we will focus on the practical implementation of feature selection technique. So where we have to write the code for feature selection technique, and then we have to check after applying feature selection technique, can we conclude that the performance of the model will improve or not? Okay. So here basically we are going to use this data set for validation purpose. You can consider this one as a data for 51 different colleges. So if I am going to open one data, one.csv, that belongs to some specific college. So if you are going to check here, just a second, it is opening. Just 1 second, it is working here. Yeah. So now you can consider these are the some features related to the student, and the last column basically represent whether the student is getting the dream job or not. Dream job means where the company is giving the package more than 10 lakhs, that will consider as a dream job. So here 0 means the student is not getting the dream job, and 1 means the student is getting the dream job. And here basically these are some features related to the student. We are going to assume like that. These are some features related to the student. And we have the similar types of 51 different colleges data, 51 different colleges data, where we are taking the 20 as a features that we use to represent the characteristics of the student, and the last one basically contain whether the student is getting job or not. Now here we are going to apply some feature selection technique, and then we are going to find what are the important features for the job recommendation system. So if we are going to use some selected set of features, then can we say the performance of the model will improve or not? So these are the seminar outlines. So first we go through the introduction or basic motivation behind the feature selection technique. Then we'll go for the type of feature selection method. What are the different types of feature selection method? Then we'll go for the feature ranking and feature subset selection method, because these are the two different category of feature selection method. So we will see one technique for the feature ranking method, and we'll see one technique for the feature selection method. Then we'll go for the principal component analysis, and lastly we will write the code for the genetic algorithm. So if we are using the GA, then in this case, can we say the performance of the model will improve or not? So mainly this session basically will focus on the practical implementation of feature selection technique. So if we are going through the overall structure of the feature selection technique, then first we are taking the data. Basically we are working for some historical data, and after that we are using some feature selection and feature extraction technique with an objective to remove irrelevant feature and select the best combination of relevant feature. Then we are using some classification technique, and after that we are going to analyze the result. After using the feature selection technique, can we get the better performance or not? Or with less number of features, can we get the similar types of performance with the models developed using the all features or not? So here the main objective of the feature selection technique is to reduce or remove the irrelevant feature and select the best combination of a relevant feature. So now we'll see how to select the best combination of relevant feature, or how we can say like that this feature is important for this objective or not. So here you can see there are two different category of feature selection technique. One is called the feature ranking, and second one is called the feature subset selection. So in the feature ranking, what we are going to do, we are using some performance parameter to rank the feature, and after that we are selecting the top 5 feature or top 10 feature, or we are selecting the top 15 feature, or optimal case we are selecting the log 2 base in number of features. So what we are going to do, we are using some performance parameter, then we are ranking all the feature, and after that we are selecting the top log 2 base in number of feature, and then we are developing the model based on only these number of features. So as for example, in our case we have the 20 feature. We are going to select the log 2 base in number of feature. That will come approximately, we are going to select the 5 features. So we are not going to use the all 20 feature. We are going to select the top 5 feature by using some performance parameter. So that we'll see how to rank the feature and how to select the top 5 feature. But in the second case, we are going to find the best combination of features. So you have the 20 feature, we are going to find the best combination of feature that will give the better feature. So if you are going through the brute force approach, then we'll consider the all possible combination. So as for example, if you have the 3 feature A, B, C, then we have to develop the model based on feature A, based on feature B, based on feature C, based on feature AB, based on feature BC, based on features CA, and based on the feature ABC. But in this case, if you are using the brute force approach, if you have the small number of features, then it is possible to find the best combination of feature. But if you have the larger feature, if you are working for the text analysis where the number of features equal to 10,000, if you are working for some biomedical area, or we are working for some domain where we are getting the number of features equal to 100, then in this case, if you are going to find the total combination, it will come 2 to the power 100 minus 1. Still in this case also it will come 2 to the power 20 minus 1. It will become the huge number of combination. Or you can also consider that for this types of scenario, you are getting the infinite number of combination, and it is not possible in finite time, or it is not possible in finite time to find the best combination of features. So here we are using the different types of approach, and one approach is called the genetic algorithm that is used to find the best combination of features. So this is also called the heuristic approach, and in this session basically we will write the code for the genetic algorithm. So these are the two different category of feature selection. One case we are going to rank the feature, then we are selecting the top log 2 base in number of features, and the second case we are going to use some type of heuristic approach that is called the genetic algorithm, and based on that we are going to select the best combination of features. Now, third case of the feature is also important, that is called the principal component analysis. Okay, that is also called the feature extraction technique. We are finding the new set of value that will give you the better pattern as compared to the previous data. So when you are using the PCA, in this case, you are getting the new set of value. In the previous case, we are not changing the value of the feature, but in the case of principal component analysis, we are changing the value of the feature to get the better pattern. That is called the principal component analysis. So now we'll use at least one feature ranking technique, then feature subset selection technique, and then we'll use the principal component analysis. And then we'll compare all the three techniques, and finally we'll make the conclusion which technique is giving the better result based on 51 different college data. Okay. So now the first one, we are going for the feature ranking technique. But before going to the feature ranking technique, we are also using one type of hypothesis testing. But due to time limit, I am not going more detail regarding the hypothesis testing, but I am only giving the basic idea about the hypothesis testing and how to select the features by using some hypothesis testing. So hypothesis testing means, as for example, we are using the four features. One is called the CGPA of the student. Second one is called the 10th marks of the student. Third one is called the 12th marks of the student. And fourth one we are considered as a branch of the student. Okay, so we have the four different features. And now we are going to find the last column basically containing whether the student is getting dream job or not. One means a dream job and zero means non-dream job. Now we are going to find, based on the CGPA, can we distinguish between dream and non-dream job or not? So basically we are going to find what is the CGPA of the student if they are getting the dream job, and what is the CGPA of the student if they are not getting the dream job. And then we are finding, is there any difference between these two CGPA or not, or these two sets of CGPA or not. And if we are getting the difference, if we are getting the difference between the CGPA of the dream job with the CGPA of non-dream job, then we will consider as a CGPA as an important feature. So we will consider CGPA as an important feature because the CGPA had ability to distinguish between dream and non-dream job. But when we are getting the same value, when we are getting no significant difference between these two set of values, then we can say there is no any difference between the 10th marks of dream job with the 10th marks of non-dream job. Then in this case, we can say this is not an important feature. Based on this feature, we cannot decide whether the student will get a dream job or not. So here we are using the different types of hypothesis testing, but in this session we are going to use the rank sum test. You can also go with the jet test, you can also go with the t test, you can also go with the rank sum test, ANOVA test. There are different types of tests are there. But when we are getting the unequal number of samples, then in this case, better we have to do the rank sum test. So here, if you are going to check the number of places student, the number of student who is getting dream job, that is not equal to the number of student who is not getting the dream job. So in this case, we have to use the rank sum test. So now you can see we are going to use here Python code. We are going to write one Python code. Okay. And if you have installed in your system Python, that is fine. Otherwise, you can also use one tool called Google Colabs. Okay. Google Colabs. There is no need to install Anaconda in your system. Directly, you can write your Python code in Google Colabs. Okay. Google Colabs. So when you will open this file, it will give you one environment to execute your Python code. If you are going to check here, it will give you one type of environment where you have to easily execute your Python code. Now you can see it is giving one environment to execute your Python code. So either you will write in the Google Colabs or you have to install Anaconda in your system. So now first we'll see how to read the data, because just you can see these are the data. We are working for 51 different colleges, and then first we are going to find whether the individual feature had the ability to distinguish between dream job and non-dream job or not. So now you can see how to write. So here we are using one package called import numpy as np. We are going to use one package called numpy. After that, we will see how to read the data. If you are going to read the data, then you can see I have written one code. Only you have to remember this code, how to read this data. This is the 2 line of code that is used to read the data. So can you please check whether my screen is visible or not, this code where I am writing the code? Anyone can you please confirm that? Anyone?
Yes, sir, it is visible.
Okay, fine. So now you can see, first I'm going to give the file location where our data is present. So we are giving here file location to this folder. So now you can see we are giving one file location equal to this. Sorry? Any problem? Yeah. So here what we are writing, file location, and we are going to read the first number of files. So that's why we have written file location str1.csv. So it will read the first file, and if we are going to execute, then here you can see this is the content of the first file. If we are going to find what is the shape of this array, we can write np.shape of this df. Then in this case it will give you the number of a student, and it will also give you the number of feature. Out of 21, 20 are the features related to the student, and the last column basically represent whether the student is getting job or not. Now we are going to find how many students who is getting job. So we are writing in1 equal to np.where. We are going to search what are the student, all the student. We are going to search with all student. -1 means the last column equal to 0. These are the student who is not getting job, and these are the student who is getting job. So basically we are finding the ID of the student who is not getting job with ID of the student who is getting job. So if you are going to check here in1, it will give you these are the student who is not getting job, and these are the student who is getting job. Now you can see. So out of 125, if we are going to calculate what is the length of those number of students, so I give the length. These are the students getting job, and again you are going to find length of in of 0. These are the students out of 125 student. 105 out of 125 students, 105 are not getting dream job, and 20 students are only getting the dream job. Now we are going to find, because we have the 20 feature, now we are going to find whether the feature had the ability, to decide whether the student will get a job or not. So we have the 20 feature. So basically we are going to find what is the feature value in case of a student is getting job, and what is the feature value in case of a student is not getting job. So now you can see we are working for 20 features. We are writing for I in range 1. It will vary from 0 to 20. For I in range 0 to 21, feature value equal to df of all column comma I. We are taking the first feature because it will start from 0 to 21. Can you please switch off your microphone? Some disturbance is coming. Yeah, can you please check? Some problem is coming. So now here we are going to use one types of test that is called the rank sum test. And we are going to store this value. So we are getting here p1 equal to rank sum test if 0 comma. I will explain what do you mean by that. And we are going to store the p value. So that's why here we are writing p value equal to np dot huge. We are creating one array to store this p value of I equal to p1 dot p value. So rank sum result had not okay p value. If I'm going to check. P1 dot p value. It's coming 1 which is going from 0 to 20. So now you can see here it is coming the p1 value df of 5 comma. This one we are getting the feature value, feature 0, feature 1, and then we are calculating the p1 value. We are going to check again. It is coming statistics, this one. Okay. So now you can see what we are going to do here. So what we are using, first we are finding what are the idea of the student who is getting, who is not getting dream job, and what is the idea of the student who is getting the dream job. So in this case, 0 and 1, and -1 means basically we are going to focus on the last column. Then we are using the rank sum test, and we are finding what is the feature value. F0 means feature value if the student is not getting dream job, and what is the feature value. Feature means the CGPA 10th marks or 12th marks if the student is getting the dream job. Then we are going to find by using the rank sum test if there any difference between these two values or not, and how to check if the p value is smaller than equal to 0.05 means we can say there is a significant difference between f0 and f1, and we can say this is a important feature. So here you can see we are going to find what are the important features are there. So here we are going to find like that in1 equal, or you can write something called in0 equal to np dot where p value is smaller than equal to 0.05. Now it will give you the out of 20 features which features are important. Here you can easily find the value. So these are the features are important. Just you can see 0, 3, 4, 1, 2 is not an important feature. So 0, 3, 4, 5, 6, 7, 8. Ninth one is not an important feature because ninth one had not ability to distinguish between the place and non-place student. Then 10th, then 11, 12 is also not important feature. 13 is also not important feature. So if you are going to check out of 20 how many features are important, we have to find the length of in0 of 0. It will represent to these number of features. Only 12 features have the ability to distinguish between the place student and non-place student. So this one we have worked for only one cases. If we are going to work for all the 51 college, then in this case how we can write the code. So just you can see for I in a range of 0 to 51, we are working for 51 different colleges. We have to take the file name equal to I plus 1. It will represent you the first college, second college, something like that. Then we are going to read the data. Once you read the data, we are going to find what are the students for that college is getting job, means what is the idea of the student and what is the idea of none get job. Then we are going to use the same thing here, whatever the code we have written here, we are going to use here J for J in range of this one. After that, we are going to find that important data equal to, before that we have to find how many features are important. So we are going to write here in0 equal to np dot where p value is smaller than equal to 0.05, and then we are taking df of all column comma in. These are the important feature. Once we got the important feature, we are going to save this file. So here we are using this command that is used to save this file. Here you can see command. Here we have to write the important data because we are going to add the last column to this one also. So we are writing df of all column comma -1, and we are going to save this data with 51 plus I plus 1. So here you can see what we are going to do. We are working for 51 different colleges. So first we are writing the file name equal to file location. We are giving the file location where our data is present. After that, we are giving the specific file name. Then we are reading the data, and then we are finding what are the student who is getting job and what are the student who is not getting job. Once we got this data, then we are going to find the significance difference between the feature. How we are going to find this is an important feature because we are taking this p value. We have to write here p value is smaller than equal to 0.05. Means this is an important feature. Then we are getting the only important feature. We are going to remove the irrelevant feature. We are taking only important feature, and then we are going to add the last column, because the last column basically contains whether the student is getting job or not, and then we are saving this file with 52 to 102. Now we have to check whether it is working or not. So it is coming some problem is coming here. Okay, so d equal to np dot, yeah, so important data we have taken here. This we have to check. Okay, so again some problem is coming, index out of bound. So here we are taking p-value of, okay, we have to take p-value of g here. Yeah. So now you can see it is working here and it has generated here these important files. So if you are going to check, you can easily find how many features are important for a specific college. Then you can easily find from here, out of this 20 feature, how many features we have selected here. So we can easily calculate by checking this file, because each college initially we have taken the 20 feature, and if you are going to check 1, 2, 3, 4, 5, 6, only 6 features are important out of 20 feature for the college number 86. And for which college we are getting the 86, 51 plus something you will write, then you will get the college number. So this is the 52, means 52 is the important feature for the college number 1. So this is the first step if we are going to apply the feature selection technique. Basically what we are going to do, we are finding the important features here. How we are finding the important feature? By using some type of hypothesis testing. What do you mean by hypothesis testing? Means first we are finding what is the idea of the student who is getting dream job, and what is the idea of the student who is not getting the dream job. Then we are going to check if there is any difference between these two set of data or not. And if there is a difference, then in this case we are going to consider the important feature. Otherwise we are going to consider as a not important features. Okay. After that, we are going for one feature ranking technique. One feature ranking technique, there are various ways to rank the feature. And here we are using one type of technique called the Gini split. Okay, that is basically used to rank the feature. Now we'll see how to rank the feature by using the Gini split. And then we will also see higher value of Gini split is best or the lower value of Gini split is best. And then we have to write the code for that. Okay, then we have to write the code for that. So if you are going to check the Gini split, how we are calculating the Gini split? First, we are taking any feature. This is your feature number 1. Okay. Then we are going to divide this feature into the different category. We are taking the lower feature or higher. So, for example, we are taking the CGPA. We are going to consider the lower value of CGPA, and we are going to consider the higher value of CGPA. So we are finding the whether the CGPA is lower or higher. Then after that, we are going to find if the CGPA is a lower value, how many students is getting job and how many students is not getting job. So now we do that in our college, total 100 students are there. And when we are taking the first one feature as a CGPA, we are getting, if the CGPA is low, 25 students is not getting job and 25 is getting the dream job. Same like that, if the CGPA is high, we are getting the 25. When we are going for the 10th marks, the same scenario, the higher value of 10th marks, lower value of 10th marks, and here we are getting the value 50, 0, and here we are getting the value 0, 50. Means the 50 students are getting the dream job and 0 students are not getting the dream job. Now will tell me which one is the important feature. But just you can see, if you are going through the CGPA, if the CGPA is low, you are going to check whether the student CGPA is low or high. If the CGPA is low, you are saying like that 50% chance you will get the dream job. 50% chance you will get the dream job, and 50% chance you have get the non-dream job, because this is the historical data. Same like that, when you are going to the 10th marks and you are checking like that, when the 10th marks is higher, then you are saying like that 100% you will get the job, because in the past history only 50 students have 10th marks, higher 10th marks, and all 50 students got the dream job, then definitely we can say like that we always ask the student to give the 10th marks. We will not ask the student to give the CGPA, because based on the historical data we are getting this one. Now we will calculate the Gini split, and then we have to check if the higher value of Gini split is best or the lower value of Gini split is best. But before that, first we are going to calculate what is the probability. If the 10th marks is high, what is the probability to the student is getting job? 1, and what is the probability that is 0? Here we are going to write here 0, and this is 1. If we are going for this one, we are going to write 0.5, or you can also write 1 by 2, 1 by 2, 1 by 2. Basically, we are calculating the probability value. And once you have calculated the probability value, you can calculate the Gini split of this node, that is 1 minus this probability value square minus this probability value square, that you are getting 0. Same like that, here we will also write 1 minus probability value square minus 0 square, we are getting 0. If we are going for this scenario, 1 minus 1 by 2 square minus 1 by 2 square, we are getting 1 minus 1 by 4 minus 1 by 4, that we are getting 1 by 2. Same like that, if you are going for this one, again we are getting the same like that, 1 minus 1 by 2 square minus 1 by 2 square, that you will get the value equal to 1 by. So here what we are calculating the Gini split value for the individual node, and here we are getting the value equal to 1 by 2, 1 by 2. The Gini split value for this node is 1 by 2, and Gini split value for this node is 1 by 2. Same like that, if we are going for this one, we are getting 0 and 0. Now will tell me the lower value of Gini split is based on higher value. Definitely we can say the lower value, because in the lower value we are representing the best type of node. So here basically we will take the lower value, and if we are going to calculate the overall Gini split, then the formula is number of sample belongs to this node 50 divided by total number of samples 100 into Gini split of this one plus 50 divided by 100 into 0, we are getting 0. For this one, we are getting 50 divided by 100 into 1 by 2 plus 50 divided by 100 into 1 by 2. We are taking this value become 1 by 2, 1 by 2. 1 by 4 plus 1 by 4, we are getting 1 by 2. For this one, we are getting 1 by 2. So what we can do, we can calculate the Gini split. And after calculating the Gini split, now what we are going to do, we are going to find which feature had the lower value of Gini split, which feature had the lower value of Gini split, and based on that we have to rank the feature, and after that we have to select the top log 2 base in number of features. We have to select the top log 2 base in number of features. So this is the another way of feature selection technique. What we are going to do, we are calculating the Gini value, and after calculating the Gini value, that we are going to find which feature had the better Gini split, which feature had the better Gini split. But this one is very simple concept. You can also write the code for that, but mainly we are going for the one important approach, that is called the genetic algorithm. And now we will write the code for the genetic algorithm, and then we will check whether the genetic algorithm will help to improve the performance of the model or not. Okay. So first we'll go through the basic approach of genetic algorithm, how we can use the genetic algorithm for any domain, either if we are working for clustering technique, or if we are working for model selection, or if we are working for feature selection. In all the cases, you can use the genetic algorithm. When you are going to search anything, you can use the heuristic approach. This is also called the heuristic searching technique. So what we are going to do in the genetic algorithm for feature selection, first we are defining the fitness value. Okay. So fitness value means this is your F is your fitness value. Now first we'll ask, what is the objective of feature selection technique? The objective of feature selection technique is to improve the accuracy of the model, or you can also say like the performance of the model, and reduce the number of features. So as for example, if we are going to get the two different types of model, one model with 90% accuracy with 4 features, and second model we are getting the 91% accuracy with 20 features, definitely we will recommend to use this one, because if we are going through the cost benefit analysis, then definitely we will recommend to use this one, because we are getting the 90% accuracy with only 4 number of features, and if you are going to achieve 1% more accuracy, then we have to take another 16 features. The similar types of approach we are also going to apply in genetic algorithm. What is our objective? Our objective is to improve the performance of the model by means improve the accuracy of the model, and parallelly we are also going to focus on reducing the number of features. So here we are going to give more weightage to the accuracy because the accuracy is the important parameter. So we are giving the 70% weightage to the accuracy. So we are writing one formula 0.7 into accuracy plus 0.3% weightage we are giving to the number of features. So that's why we are writing how many features we are selecting, means maximum number of features minus number of selected features divided by maximum number of features. Because if we are using this formula, then we will get the value between 0 to 1, and here we are also taking the accuracy value between 0 to 1, because 20 minus number of this value divided by 20. If you are taking lower value, definitely the value of this one will improve, and if you are taking the highest number of features, then definitely the value of this component will reduce. And our objective is to maximize this both the component. So that's why we have defined one fitness value. We have defined one fitness value. How to define the fitness value? We are taking the 70% weightage we are giving to the accuracy, and the rest 30% weightage we are giving to the number of selected features. So how many features we are taking? In the case of genetic algorithm, there are three different approaches. The first one, we are taking the chromosome. Okay, that is collection of the gene. Second one, we are taking as a crossover, and third one, we are taking as a mutation. Okay, there are three different approaches out there. Chromosome means basically you can consider as a solution. So initially we are taking how many possible solution you are taking, that you will consider as a chromosome. So here we are taking the solution means that has the length of 20. Basically it will contain only 0 or 1. 1 means for this solution we are going to use this feature. So as for example, now you can see we are taking 1, 2, 3, 4, 5, 6. Okay, so here we are writing 1, 2, 3, 4, 5, 6, 7. If you have the 7 feature, and if you are writing chromosome number 1, it will contain 0, 0, 1, 1, 0, 1, 0. What do you mean by that? The solution 1 is saying like that. If we are going to develop the model with feature number 3, feature number 4, and feature number 6, what is the performance of the model? What is the accuracy of the model if we are going to develop this model with feature number 3, 4, 6? Same like that, we are taking the second chromosome, it will give the same like that 1, 0, 1, 0, 0, 1, 1, something like that it will give. So again, we have to take the same like that. So now you can see in this case how we can generate this type of feature. If we are going to check, I have already written one code here. Now you can see. So here we are going to generate, if we are going to check, we are writing here chromosome CH equal to, we are taking the 50 different chromosome, 50 different solution and 20. Now we are going to find which solution is the best solution. We are going to check here, this is the chromosome. What do you mean by that? The first chromosome is saying like that, if we are going to develop the model with feature number 1, feature number 2, feature number 4, 5, then this is the feature you have to count. If you are going to develop the model with this number of feature, you can also calculate here. C equal to CH of 0, all, and then we are going to find IN1 equal to NP dot, where we are getting. Now you can see the first solution is saying, if we are going to develop the model with 0, 1, 3, 4, 7, 9, 12, 14, 15, 16, and 19, what is the performance of the model? What is the accuracy of the model if we are going to develop the models by using this number of features? So means for each chromosome, we are going to calculate the fitness value, and after that we are selecting the best chromosome. We are going to find what is the best chromosome. What is the best chromosome we are going to find by using the fitness value. Once we got the best chromosome, then we are going for the crossover and mutation. What do you mean by crossover means? Basically, we are taking the two different solutions. This is the solution number 1. This is the solution number 2. We are going to merge these two solutions and we are generating one new solution. That is called the crossover. What do you mean by that? The new solution, basically we are taking half part of this solution and half part of this solution, that becomes the new solution, and the new solution will contain the capability of first two solutions. These two solutions, it will contain the capability of these two solutions. That is called the crossover. Same like that, if you are going for the mutation, we are simply changing 1 to 0. Some places we are going to mute it. So as for example, based on 7 feature, we are getting the accuracy 93%. After that, maybe slightly if you are going to modify the code, if you are going to change only 3 to 4, only 1 to 2, then it may be possible you will get the 94% of accuracy. It may be possible. So here this approach is called the mutation approach. So now we will write the code for crossover and mutation, and then we will also write the code for the fitness value. So first we are going to define the code for a fitness value. Okay. So here you can see we are going to write the same code here. We are going to write one code for the fitness value. So we are defining here, define fit value. We are writing one code for the fitness value, where we are going to take the data as input, because based on the data we have to find what is the accuracy of the model if we are using this feature. Then we are taking here chromosome CH. CH means you can consider as chromosome. Then you can also consider number of chromosome. If you are not taking, that is also fine. First we are going to find what is the total number of solutions are there. So NOS means the number of solution equal to NP dot shape of CH of 0, it will represent the number of solutions. Here CH means chromosome, that is the 2-dimensional, and if you are writing NP dot shape means it will give you the number of row, and each row basically used to represent one type of solution. So if you are getting the total number of solution equal to NOS. After that we are going to find for each solution. For each solution, we are going to calculate what is the accuracy of the model. Means we are using some type of machine learning approach. So here you can see we are going to use this number of machine learning approach. We are not going to make the conclusion based on the single machine learning approach. You can easily search. If you are going to use the Gaussian net-based classifier, logistic regression, decision tree, k-nearest net-based classifier, you can also use the multinomial net-based classifier. So if you want to use the multinomial net-based classifier, you can simply search here sklearn. If you have no any idea, you can simply search sklearn multinomial net-based classifier. So you can easily search, and here you will get the code for that. There is no need to remember the code. Here you can directly get the code for that, and here you will also get the idea how we are going to use the multinomial net-based classifier. So we are going to use the multinomial also net-based classifier. So Gaussian basically it will work as a when we are taking the feature as a continuous, multinomial when we are taking the feature as a discrete. Then we are using the logistic regression, either we use or not use, decision tree classifier, k-nearest classifier, and support vector machine. So better we are going to use only 5. So I am going to remove logistic regression. So now you can see we are going to how to use this model, the simple approach. You can see how we are going to use. First we are going to define one list, and where we are going to put all the models. Simple. We are going to write model equal to whatever the terms you have written here, you have to write CTRL-Z, CTRL-C, simple. Now you will write m dot append of m. This is the first model we are using the Gaussian, and then only you have to do the copy paste. What we are going to do, just you will see, I will explain you the whole concept. Now you can see. First one we are using the Gaussian. Second one we are using the multinomial. You can simply write here multinomial. Then we are using the decision tree classifier. You can simply write here decision tree classifier. Then we are using the k-nearest classifier. We have to use right here k-nearest classifier. Then we are using the support vector machine with classifier. So we have to write support vector machine dot support vector classifier. And where we are using the kernel equal to linear. So now we are using the 5 model, model 1, model 2, model 3, model 4, and model 5, where we are writing support vector classifier, and where we are writing the kernel equal to this one. So here you can also check. Now I'm going to check that you can rightly or yeah. So that is called the support vector classifier, kernel equal to linear. Support vector classifier. Now you can see, now we are going to calculate what is the accuracy of the model if we are using the first solution, so if we are going to calculate the accuracy of the model, we have to use some data for training and some data for testing. So here we can use one concept called train and test split. You can also search here how to use train and test split in sklearn. You can easily get the code for training and testing split, where we are going to divide the data into the training and testing part. So here we are also using one technique called train and test split, where we are going to find what is our training data and what is our testing data. And here you can see we will easily get the code. This is the code we have to use to divide the training and testing data. So now you can see we are going to use the 30% data for training, testing, and rest 70% data for training. So here we are writing data of all column 0 to -1, because these are the features, and the last column basically contain your labels. So we are writing here. See, so here what we are writing here, we are going to find what is our training data and what is our testing data, and you can also write this is your training data, TR data. X test means this is your testing data, we are writing TS data. Y train means this is your actual data, so we are writing TR actual, and Y test means we are writing the TS actual. TS actual. So here what we are getting, TR data means training data that is used to train the model. TS data means that is used to test the model. TR actual means these are the actual data. These are the actual training data. Means this is your actual feature data and this is actual training data. TS actual means based on that we are going to validate what is the accuracy of the model. So whatever the data we are using for the training, that is totally different from the data used for the testing. And here we are also going to use one technique that is called the normalization. We are going to normalize the data. So you can see here we are using one technique called normalization. We are going to put all the data in one scale, so that's why we are using one technique called normalization. So now you can see. So now after that, after getting this data, after getting the data as input, we are going to normalize the data. So we are writing data of all column 0 to -1 equal to. We are going to normalize only the feature, because the last column basically contain your labels. So we are not going to normalize the labels. We are only normalizing the data of all column 0s to -1. So now you can see, so we are going to normalize the data. We are going to bring all the data in one scale. We are going to bring the data between 0 to 1, and then we are finding whether these features are important or not. So we are going to normalize the data between 0 to 1, and here 0 to 0 column -1 means we are selecting the feature 0 to second last, because the last column is basically represent your actual data, whether the student is getting job or not. After getting this one, now we are going for the features. Okay, so here we are taking the how many sample. For each sample we are writing for I in range of 0 to number of samples. How many samples are there? Now we are selecting what is the feature value for the sample. We are writing ch of I comma all column. Means we are working for the ith solution. I means it will start from 0 to number of solution, and we are working for ith solution. For ith solution, we are going to find the important feature. So we are writing important feature equal to np dot where we are getting the feature value double equal to. Once we got the important features, we are also going to calculate what is the accuracy value or what is the fitness value. We are writing fitness value equal to, we are creating one array that is used to store fitness value. So we are writing np dot 0 number of solution comma 3. This is called the fitness value. We are going to store here. Now after that we are finding what is our training data become. Training data for this sample, so it will become, or you can also write something like that, for j in range 0 to 5, because we are using the 5 different types of model. We are writing here model equal to m of j. We are getting the model. We are going to fit the model. Model dot fit equal to tr data comma tr actual. Then we are going to calculate model dot predicted TS data. So now you can see here what we are going to do. TR data and TR actual means we are training the model, and TS data means we are finding what is the predicted value for this testing data, and we are also going to store this value. So we need one value that is called predict equal to np dot 0. That size is equal to size of the testing data. So that's why we are writing np dot shape of ts data of 0, comma 5 features. So we are writing here 5. Now we are going to store this value PRED of all column j equal to this one. So what we are going to do, if you are going to check carefully, we are using the m equal to j equal to 0 means we are using the Gaussian, j equal to 1 means we are using the multinomial, j equal to 2 means we are using the decision tree, j equal to 3 means k nearest neighbor, j equal to 4 means support vector classifier. So we are using the each model and then we are training the model, and after that we are going to find what is the predicted value for this testing data, and that we are going to store in predicted 0, that we are going to store in predict 0. Once we will come after this loop, means we have already used the 5 different model, and then we have calculated what is the predicted value if we are using this feature. Now you can see how to use this feature. Now you can see we are going to write here IMPF. This is called the important feature, and here we are also writing all column comma IMPF. We are using this one as an important feature. Now what we are going to do here, you can see what we are using. First, we are finding for the chromosome number 1 is suggesting what are the important feature. Now we do that 1, 3, 5, 7. Now we are training the 5 different model by using 1, 3, 5, 7. Then we are going to find what is the predicted value for first model, what is the predicted value for second model, what is the predicted value for third model, what is the predicted value for fourth model, and what is the predicted value for fifth model. And we are going to store in one array that have the 5 different column, and the first column it will represent the predicted value using the Gaussian, second column represent predicted value using the multinomial. Now we are going to find how many models are saying like that whether you will get a job or not. How many models are saying like that you will get the dream job. So here what we are going to do, if we are going to check, we are writing predict equal to np dot sum of PRED, where we are writing x. What we are going to do here, we are finding the how many are saying like that you will get the job. You will get the job in this one. So just I am going to check whether we have tried x is equal to, yeah, x is equal to 1. So here what we are writing, we are going to find how many models are saying like that we will get the job, and if majority of the model, if at least 3 models are saying like that we get job, now we have considered as a actual job, means definitely we will get the job. So here what we are going to find, we are going to find how many models are saying like that we will get the job. So in1 equal to np dot where we are getting the PRED value greater than equal to 3, and in2 equal to np dot where we are finding what are the samples where predicted value is coming less than 2. Now what we are going to do, just you can see the simple approach. Now assume that we are using the 5 different model. This is your HOD of the department, this is your placement head of the department, as professor of the department, assistant professor of the department, and 4th year student of the department. Now what the student is doing like that, they are coming with the resume and then they are asking, sir, can we get the job in dream company or not? And then they are interacting with all the models. These are the models. Basically they will check the resume, and after that they will suggest whether we will get the dream job or not. Now assume that HOD is saying like, yes, you will get because you have the good CGPA, you have the good performance. Professor is also, placement division head is also saying 1, professor is saying 0, then assistant professor is saying 1, 4th year student is saying 1. Definitely this student will consider as a, definitely I will get dream job because the majority are saying like the dream job. That's why we have considered a dream job. So now you can see here we are also doing same like that. If at least 3 models are saying like that we will get the dream job, then we will consider predict of in1 of 0 equal to, we consider 1, and then we have to write predict of in2. If less than 3 is saying like that, then we will consider as a 0. Now we got the predicted value. Now we are going to calculate the accuracy. So we will search how to calculate accuracy by using sklearn. So sklearn accuracy score for classification problem. Yeah. So simply we have to open this file. Now you can see here it is coming. How to calculate the accuracy? It is also given the formula. You can use this as a package. We are going to use the same like as a package. Then it is asking to write how to calculate accuracy. You have to use this formula to calculate the accuracy value. So we are writing here this formula to calculate the accuracy value. We are writing this one where y true is our TS actual, and y prediction is our, basically we are writing predict. Once we got this one, we are going to store this value in the accuracy fitness value. We are writing here fitness value of this, all the thing we have to write here. Fitness value of I comma 0 equal to, we are going to write this accuracy score. So how much accuracy we are getting here, we are going to write in the fitness value. How many features are there, we are going to write also fitness value of I comma 1 equal to number of features. How we can find the number of feature? By using this one. So this is the basically the number of features. We are writing length of important feature. Okay, once we got this one, what is the fitness value of I comma 2? Because we have given the 70% weightage to the accuracy, so we are writing 0.7 into this one, and then we are giving 30% weightage to the number of features, but we have the 20 features minus length of this value, divided by, you can see. So we have written this formula. After that, we are going to return the value of return FTV, return fitness value. Now we have to check whether it is working or not, or is there any problem with this code. So now again we are taking this data. Here you can see we are taking this as a one data one. Then we are going to create one chromosome. So we are writing np dot random random integer. We are random integer 0 to 2, and we are creating 50 different solutions with size 20. Once we got this one, now we are going to calculate fitness value equal to this function we are calling the fit value function. We are passing the data as an input, that is called the df. Now we have to check here, one problem is coming. So a model dot fit. Okay, so here we have used the same thing, whether you have to write model 1 dot fit, model 1 dot fit, model 1 dot predict. Now we have to check whether it is working or not. So list has no object attribute model. Okay, so what we have done here, m equal to this one, then we have created model. Okay, so here we have to write model, not the m. Here we have to write model. We are going to append model, not the. Now we have to check again. Again it is coming, tr data is not defined. Tr data. Okay, tr data. Fine. Again it is coming, what problem is coming? So found the error of dimension 3, but expected error where it is coming. Okay, so model 1 dot predict. So now we have to also check what is the, 1 second. So yeah, and this one we are going to check chromosome. So it is coming from the error. Okay, so which case it is coming the problem. Okay, so here we are writing fitness value this one. So it is coming model 1 dot predict of tr data of important features. We have taken this is as important features of 0 we have to write, and here we have to also write important features of 0. Yeah, so now you can see we are getting this as a fitness value. Now you can see. So here what we are getting like that, just to tell us, if we are using 9 features, we are getting the accuracy 78.94. Now you can see here we are getting the overall with 9 features, we are getting this one. With 7 features, we are getting the accuracy of 81%. So definitely the second one is better than this one. Now you can see the fitness value. The higher value of fitness value basically represent the best solution. And here if we are going to check that in this case we are getting the higher value in the third case. If we are going to check, this is the maximum value, and which case we are getting the maximum value, we are getting in this case with 7 number of features, we are getting the accuracy of 81%. So here you can see we are getting the number of features, and we are also getting this one. Now we have to find which one is your best chromosome, in which case you are getting the best solution, in which case you are getting the best solution. So we have to find what is the maximum value we are getting for the third column, because that will represent the actual fitness value. We are ranking the chromosome based on the third column, not based on the first column and second column. So here we are finding the what is the maximum fitness value equal to NP dot max of FTP of all column. This is called the maximum fitness value. If we are going to check the max fitness value, we are getting this one at a max 0.811. We are also getting 0.811. Now we have to check where we are getting 0.811. Again, we are writing IN1 equal to NP dot, where we are getting the FTP fitness value of all column 2 double equal to max F. Now you can see we are getting here IN1 of 0. Here you can see. So this is the column. If we are going to check here FTP fitness value 20 number column where we are getting 0.81. Now you can see with 4 number of feature we are getting the equivalent accuracy. With 7 feature you are getting 81.57, and with 4 feature you are also getting the same accuracy. So definitely we recommend to use this 4 feature, and here you can see we are getting this one. Okay, it may be possible in the future, it may be possible it will also improve the performance if we are using the crossover and mutation. If we are using the crossover and mutation, then definitely the performance of the model will improve. Okay, so this is the only one part we have written, here. So now you can see, so one chromosome we have taken. Now we are going to write the code for the crossover and mutation. So we are writing define, where we are going to pass the chromosome as a input. So we are writing here crossover. That code I have already written. Due to the time limit, I am not going for the crossover and mutation code, but just I have written the code for the crossover. I am using the same code, and that code I have written for the mutation, because due to the time limit, I am not going for the crossover and mutation separately. But you can see the objective of the crossover, we are taking the 2 different chromosomes, and then we are taking half of the first chromosome and second half of the second chromosome, and then we are generating one new chromosome. That is called the crossover. Next one we are going for the mutation. Okay, so now you can see this is the approach. Now we are going to write the final genetic algorithm, that is called the define final GA feature selection technique. That will take your data and it will return you the number of best feature. It will return you the best feature. Okay, which one is your best feature, it will return you the best solution. So now you can see, so first what is the approach? First we are going to create the chromosome. Same like that, we are creating the chromosome. This is the first approach. After creating the chromosome, we are going to calculate the fitness value. So we are going to call this function that is called the fitness value. Once we got the fitness value, before that we are also writing what is our maximum fitness value. Initially we are getting the 0 maximum fitness value, and what is our best chromosome, best CH, we are also writing nothing because we have not got any best chromosome. So we are writing maximum fitness value equal to 0, best chromosome equal to 0, and then we are going to continue for I in range, or this is also called the number of generation in range 0 to 100. We are going through the 100 generation, and then we are finding the best chromosome. Now we can see we got this value. Now we are finding what is the maximum value of the chromosome. We are writing here this one. You have to write max, only the maximum value of the fitness of the current generation G. This is the value we are getting. Then which chromosome we are getting the maximum value, we have to write again this value. That one will represent which chromosome we are getting the maximum value. So we are writing FT of this one, MF of G. Okay, if the current fitness value, this is the current, if greater than your global fitness value, then we have to replace. So here we are writing if the max fitness value greater than or smaller than equal to, this is your current fitness value, then in this case we have to replace max fitness equal to this one. And then we have to write the best chromosome. What is your best? CH equal to best chromosome equal to CH of this index IN1 of 0, all column. That we got the best chromosome. Once we completed this one, then we are going for the crossover and mutation. So we are using this one. So now we are generating new chromosome equal to NCH equal to crossover this one. Okay. Then we are creating the mutation also, new CH equal to, we are going for the mutation mutation. Once we got the crossover and mutation, then we are going to, because when we are doing the crossover and mutation, we are getting the half part. Then we are going for the new ch of 0 to 25, because the first half we are taking the 50 chromosome equal to NCH and CH of this one. I will explain what do you mean by that. 25th to end, comma, whole chromosome. We are taking again, we are generating the new chromosome. So we are writing this one and we are writing here 25. So what we are going to do here, if we are going to check, we are taking the two chromosome. Here we are taking the two different, we have the 50 different chromosome, then we are making the pairing. So we are getting the 25 pair. For each pair, we are getting the two different chromosome. We are generating a new chromosome by taking half of the first chromosome and second half of the second chromosome. That is called the new chromosome. So if you are giving 50 as a input, you are getting 25 as a output. So that's why we have written here 0 to 25 this one, and this one is 25 to all this one. After that, when you are going to complete this solution, then it will return you the best fitness value. It will return you best chromosome, will return you the best chromosome. So which one your best chromosome, that will represent your feature. So now we are going to check whether it is working for our data DF or not. So we are going to write here DF. Now we are going to check whether it is working or not. So again, some problem are random is not defined. Okay, so we have to write import random. So cannot broadcast 50 20 comma into 20. So we are writing here mutation in CH. Just 1 second, print. Okay, 1 second. So now it will start working here. So we are writing here final feature selection, final set equal to this one. So now you can see it is working. It will take some time to give the output. It is working here because we are using the genetic algorithm. So definitely it will take some time to find the best combination of features. So now you can see it is already calculated. This is the best combination of features. We are one represent like that. You have to use only this feature to find the best combination. So later I am going to reduce this number of features, the number of generation 50, and then we are using the same like that whatever we have used for this one. Yeah, some disturbance is coming, so can you please stop it? Yes. Yeah. So now you can see once we got the data, now we are calling this feature selection technique. How to call the feature selection technique? We are calling this one as a feature selection technique. So we are writing this one final set equal to this one of DF. We are calling the feature selection technique. Once we got the feature selection technique, we are going to find what are the features are important. So we are writing FS double equal to 1. That is your important feature. So here we are writing the important feature, and then we are going to save this data with 102 plus I, means after 102 plus 1, we are going to save this file with feature selection. That is called the genetic algorithm. And we are also going to print here, print I. You can see we are going to execute it will start working here. If we are going to check the overall algorithm of the feature selection technique, this is the overall algorithm we are using. How we are running? First, we are taking the initially n number of chromosomes, means n number of solution. Then we are computing the fitness value. I have already written the code for the fitness value. If we are going to check, this is the code we basically use to calculate the fitness value. This is the code basically used to calculate the fitness value. Once we got the fitness value, then we are going to check whether we are reaching our stopping criteria or not. So we are using here 50 different generation. We are going to the 50 generation, and then we are finding what are the best combination we got. That is called the generation. Then we are going for the mutation and crossover, and after that we are going for the new generation, and we are going to follow the same approach. We are going to follow the same approach to generate the new set of features. So now you can see it start working here. It will work for 51 different projects, and it will generate the best combination of features. After developing this one, now we are also going to check in which case we are getting the better solution. Because we have used the three different combinations. One is your all feature. Second one, we have selected the feature using the significant feature, and third one, we are using the genetic algorithm. So now we are going to check in which case it will give you the better result. So again, we are going to use the same of 5 different models, and then based on this 5 different model, we are going to conclude that in which case we are getting the better solution. So here you can see again we are going to define here model number 1, where we are going to pass the training data, training actual and TS data. And this model basically we are using this one, that is called the Gaussian classifier. So again, just you can see we are creating one model, Gaussian naive classifier. Model.fit, we are training the model based on the TR data, TR actual. Once the data is trained, we are going to create the predicted value is equal to model.predict predict of TR TS. Now you can see the first model is clear. We are going to return the value of PRED. Once it is running, we are also going to complete this one. Fine. We are going for the model number 2, model number 3, model number 4, model number 5. Only you have to do the copy paste here. Just you can see the second one we are using. Later you have to copy from here. It will become easy for you. Second one we are using the multinomial. So in place of the Gaussian, we have to write multinomial. That is a multinomial model. Decision tree classifier, we have to write here decision tree classifier. Then k nearest neighbor classifier, we are going to write here k nearest neighbor classifier. That we are using SVM with support vector classifier SVC, where we are writing kernel equal to linear. You can also take the polynomial kernel. You can also take the next different types of kernel, that is called the RBF kernel. So we are also writing polynomial kernel and we are also writing the RBF kernel. So now you can see we have written the code. This one we are writing 6th and this one your 7 model. So we are defining the 7 different types of model where we will pass the training data, training actual and testing data, and it will give you the predicted value. Once you got the predicted value, you can easily calculate the accuracy. So what is the accuracy of the model if you are using the single Gaussian naive-based classifier? What is the accuracy of the model if you are using multinomial? What is the accuracy of the model if you are using precision tree? What is the accuracy of the model if you are using k nearest neighbor? What is the accuracy of the model if you are using the support vector classifier with linear kernel, polynomial kernel, and RBF kernel? Once you have executed, that is fine. Now we are going to find for all the models. So here we have to do the same copy paste, because we are working for the same models. Once we got the data, now we have to find the training data and testing data, but before that we have to normalize the data. So we are using this normalization technique. Before going to the model development, we are going to normalize the data. So we are writing here and data or later you have to write the df, or here you have to also write the data equal to this one, data of all column comma 0 to -1 equal to normalized data of all column. We are going to normalize the data. After normalizing the data, we are going to use the train and test you can use, or you can also use the cross validation, because most of the cases we are going to use the cross validation. We are not using the training and testing. So here better we are going to use the cross validation, and based on that we have to make the conclusion which model is giving the better result. We are writing the k-fold cross validation, then we are finding what is our training data and testing data. So now here you have to check. This is our training data and testing data for this and data. Once we got this one, now we are going to calculate what is the predicted value. We are writing predicted value. How many models we are using? So np.0, that is one array we are creating to store the value. np.shift of data of 0, and we are using how many models? We are using total 7 models. So we are writing 7 models. Now we are going to store this value predict of this test index comma 0 equal to, we are calling the model number 1, model one, and same like that we have to call the other model. So once all the models will train, now we are going to calculate the accuracy of the model. So again, we have to write, we are using the 7 models. We are writing for J in a range of 0 to 7. We are going to calculate the accuracy. So we are writing here ACB accuracy equal to NP dot 0. We are using 51 projects. So we are writing 51 comma 7. So for a range of this one, now we are going to calculate the accuracy ACB of I comma j equal to accuracy score, whatever you have written here. For the fitness value, we are going to do the same thing. Predict of all column and j. Now you can see what we are going to do here. We are calculating the accuracy for the predict of j. Why we are writing j? Because here we are storing the 0th column. We are storing the what is the predicted value using the model 1, what is the predicted value using the model 2, model 3, model 4, model 5, model 6, and model 7. So for all the models, we are calculating the accuracy value, and we are going to store in one variable called ACB. That will calculate the accuracy value for different data by using the 7 different types of model. So now you can see it is already completed up to 10, already completed up to 10. So we are going to reduce the number of features so that it will become a little bit faster. So it is already working for 10. So we are going to stop it because it is taking the time. And now here we have to reduce the number of features where we have written the final GA. Instead of going to the 10, we are going to the only the 10 different generation, and we are going for the 11 to 51. So now you can see it will become a little bit faster. But if you are going for the more generation, we will find the better solution. So total, how many data we are getting here? 51 into 3. So here we have to write also 51 into 3. And here we are also writing 51 into 3. So we are using these number of models. So once it will complete it, just will wait for 2 minutes. So up to here, if you have any question, then please ask. If you have any question related to the code part, please ask. Because due to the time limit, I am going a little bit faster. So if you have any question in any component, then please ask, because it is taking some time. 27 already completed. So anyone, any question? If you have any questions, then please ask. Anyone?
Sir, I have a question regarding the functions.
Yeah,
When we compute these weights, or when we talk about the support vector machine,
yes.
sir, there are many functions like sigmoidal function, Bayesian function. Which
Yes.
function is the most optimized function that can be used?
That you cannot give the guarantee. That will totally depend upon your data. That will totally depend upon your nature of the data. If the data is linearly separable, then in this case, the linear function with the linear kernel will give you the better result. So that will totally depend upon your data. And based on the data, we are going to find which one is the best model.
Okay, sir. Okay. Thank you, sir.
Yeah. Now, anyone, any other question? Just you can see 48 is already completed. Again, I am also going to write here print I so that we can also check the status print I. And once it will complete that one, it is also model 1 is not defined. We have to execute this one. That is the model 1. Now we have to execute. And so kernel equal to linear kernel. We are going to write this one. And subtract the input variable consistency in 25 comma this one. Okay, so shape of data 0, and then we are calculating the predicted value. Okay, yeah, fine. Data. So now you can see it start working here. After that, we are also going to shape this accuracy value so that we can easily find that which case we are getting the better result. So now you can see it is working here. If you are going to check, the code is working here. If you are going to check here, the code is going to start working. So working for 101, but we have to check. So 109 already completed. It will take 2 minutes time to complete the rest of it. $122. Total 153 different data are there. So we are going to encourage that. 143. Yeah, so that is completed. So if I am going to check the accuracy value, because in my case the Excel is not working, so that's why I'm not going to open here. I'm going to open in the MATLAB. Document. of ACB dot CSV. So now you can see this is the models we are getting here. So this is the first model, second model, third, fourth, fifth, sixth, and seventh. And this is the accuracy of the models we are getting here: 59.62%, 68%. Means if you are using the assembled technique, then definitely the performance of the model will improve. So now we are going to compare which model is giving the better result. If you are going to plot here box plot of ACC, you can easily find which model is giving the better result. So here you can see, if you are going to write here on, you can easily compare which model is giving the better result. So here you can see the fourth number models, 4th, 5th, and 6th are giving a little bit better result as compared to the 1, 2, and 3. So what is your 4th, 5th, and 6th? That is the models related to the support vector classifier that is giving the better result as compared to this other techniques. So if you are going to check that model, it is giving the better result as compared to the other technique. And what are the 4th, 5th, 6th? Here you can easily check. The 4th number is your k-nearest neighbor classifier. 5th number is your support vector classifier. Then we are using the support vector classifier with polynomial kernel, support vector classifier with RBF kernel. So if you are using these types of model, it will give you the better result because it has the higher value of average as compared to the other technique. Same like that, you can also compare the different set of feature, because the first 51 data you are getting for the original feature, the next 51 you are getting for the significant feature, and next 51 you are getting for the principal component analysis. So you can also find which technique is giving the better result. So here you can see we can also write like that, because for the box plot diagram you have to put all the accuracy for the model, for the all feature in one column, all accuracy for the second feature in second column, and third column. So we are doing like that for I equal to 1, 2, 3, because we are using the 3 different techniques. Each technique we are using 51 times. So we are writing for j equal to 1, and then we are writing AC of each time we are using 7 times. So 7 into j minus 1 plus 1 to 7 into j, comma I equal to ACC of 51 into I minus 1 plus j comma all column. So now you can see here we are going to write, this is the performance we are getting when we are using all feature. These are the performance we are getting when we are using the significant feature, and this performance we are getting when we are using the genetic algorithm. So again, if you are going to write the box plot of AC, you can easily check in this case, in case of significant feature, we are getting the better result as compared to the all feature. If we are writing grade on, then in this case, we can easily observe that here we can see with the less number of features, we are getting the better result as compared to this one. Same like in the case of genetic algorithm, we are getting the similar types of performance, but in the GA approach, we are using the less number of feature as compared to the all feature, because the first box plot that will represent your all feature, second box plot will represent your significant feature, and third one represent your GA. But in the GA, we have only executed 10 iteration, 10 generation. Basically, we have to execute for the 50 generation. And when you are going for the 50 generation, definitely we get the better set of matrix that will give you the better result for that case. So in this case, just you can see with the less number of feature, we are getting the better result. Means we can say like that the feature selection is important to improve the performance of the model. Here you can also compare the models by using the hypothesis testing. Here you can see we can also write for I equal to 1 to 3, for j equal to 1 to 3, and p of I comma j equal to rank sum of AC of all column I comma AC of all column j. Again, we are using the rank sum test. And if you are going to check here the p-value, here you can see in all the cases we are getting the p-value. If you are going to check these two cases, we are getting the p-value greater than 0.05. Means there is no any significance difference between the models developed using the all feature with the models developed using the significant feature. Both are totally same. There is no any significance difference. But in the all feature, you are using the 20 feature. But in the case of significant feature, you are using the less number of features. So definitely we have to give more weightage to significant set of feature. When you are using the genetic algorithm, you are getting the totally different, but that is also similar. This is your genetic, that is also similar to your all feature. Whatever the models you are developing based on the genetic algorithm, with all feature both are same. But in the case of genetic algorithm, you are using the less number of feature as compared to the all feature. So definitely you can see here the conclusion is there is a benefit of using the feature selection technique. If we are going to remove the irrelevant feature, the performance of the model will not change, even the performance of the model will improve. Clear? So if you have any question, then please ask. If you have any question related to the code, then please ask. I will share you this code. You will go through this code, then you will get more idea about the feature selection technique. So up to here, if you have any question, then please ask. Anyone, if you have any question, then please ask. From my side, it is completed.
Hello, good evening, sir. Sir, I have one question.
Yeah, tell me.
Sir, what is cross validation?
Yes. What is?
Cross validation.
Yeah,
how can we cross validate our model?
Cross validation, just you can see. Previously, we are using the train and test validation, where we are using the specific data for training and a specific data for testing. Okay. So in this case, what will happen like that? When you are executing your program in your system, you are getting the accuracy 95%. But second time when you are going to execute your program, then you are getting the accuracy 75%. It may be possible because the performance of the model totally depend upon your training and testing data. Okay. Now, in the case of cross validation, we are using each data for training and testing. What we are going to do, we are dividing this data into the 5 different parts. Either you are using 5-fold. If you are using the 10-fold, you have to divide the data into the 10 different parts. At a time, we will use 9-part data for training and 1-part data for testing. And you have to continue this process 10 times. And then you will make the conclusion. Okay, what are the conclusion you are getting? That is called the cross validation.
Okay.
Yeah. So definitely nowadays we are using the cross validation technique, because in the cross validation, whatever the conclusion you are going to make, that will consider as a general conclusion. Nowadays we are not using the holdout method.
Okay.
Okay.
So cross validation is basically used to test the model.
Yeah, test the model. That is called the validation method. That is also used to overcome the problem of overfitting. That is also used to overcome the problem of overfitting.
Okay, sir. Okay, sir. Thank you.
Anyone? Any other question?
Sir, what is hyperparameter tuning?
Hyperparameter tuning. Hyperparameter tuning basically we are using for, I think, for support. That I have not that much confirmed idea, but hyperparameter tuning basically we are using in support vector machine. That I have not exact idea about the hyperparameter tuning.
Okay.
Yeah. Next, anyone? Anyone, any question?
Sir,
Yeah.
sir, actually, when we are working with deep learning, where we implement various transfer learning models, so can we evaluate our model accuracy as you represent, like in box plot?
Yes,
like actually.
No, model accuracy means, just you can say whatever we have done, that is for the classification problem. If you are going for the clustering problem, we will use this different one. Now you are saying like that you are working for the transfer learning, right? Okay.
Yes.
Transfer learning is you are going to translate some language, or you are going to translate some image. What you are doing in using the deep learning? Transfer learning is basically we are, yeah. Tell me.
in transfer learning, I'm basically classifying the image data.
That is a classification problem that you cannot say like that. This is called the transfer learning. Classification, if you are using some type of CNN models or you are using the deep learning model, right? For the classification problem, where you are going to classify the X-ray data or some other data into the different classes. Okay. In this case, you can use the accuracy parameter. Okay. You can use the accuracy. Always you will try to put your result in some graphical format. Because just you can see, if I am going to ask you, if you are going to check this one second. I'm going to share my screen. Okay. Can you please check my screen is visible or not?
No, sir, it's not visible yet.
Okay. It is not coming the sharing option now.
Yes, sir, it is visible.
Okay, so now you can see. So, as for example, now assume that in paper you are writing this one the accuracy. What you are writing ACC into 100. ACC equal to ACC into 100. So you are writing this accuracy parameter. Most of the cases, what we are observing like that, you are creating one table and you are putting all the data, and then you are making the conclusion like that. Support vector machine with linear kernel is giving the better result. Now, in this case, the reviewer will also validate your conclusion, whether you have given the right conclusion or not. When they will check this data, it will observe like that. Some case the SVM is giving the better result, some case logistic regression is giving the better result, some case NN is giving the better result. So that will confuse. But if you are going to give the box plot diagram, that in this case there is no any confusions are there. If you are going to give this types of box plot diagram, box plot diagram of ACC, here you can see there is no any confusion. Within a minute or within a second, it will decide whether you have given the right conclusion or you have given the wrong conclusion. Okay, because the model which have the higher value of this average, this is also called the median, the red line. The model which have the higher value of this red line, that will consider as a best model. So if you are writing here grade on, you can also write here set value. You can give the different technique names. What are the 7 different techniques we are using? We can write like that. So here you can see we are using the 7 different types of technique. What are the techniques we are using? The first one is your multinomial net-based classifier. Second one is called the Gaussian net-based classifier. Third one we are using the decision tree. Fourth one we are using the KNN. Fifth one we are using the support vector machine. So SPM with linear. Sixth one we are using the support vector machine with polynomial. And 7th one we are using the support vector machine with RVF kernel. So if you are going to write this types of thing, you can easily compare. Now you can see, you can easily say like that support vector machine with the polynomial kernel is giving slightly better result as compared to the other technique. Okay, but again, most of the time we are going to stop here, but you have to also prove that this model is significantly giving the better result as compared to other techniques. How to prove that? Again, we have to use the hypothesis testing. So whatever the hypothesis testing we have used here, again we are going to use the hypothesis testing between all the models. Here we are going to write ACC. Now you can see. So here you can easily compare. If the value is coming less than equal to 0.05, these models are totally different. Otherwise, models are same. So this is your support vector machine with polynomial kernel. Now you can see this models and second one Gaussian model both are same. This model and support vector machine with linear kernel or k-nearest neighbor both are same. There is no any difference between the support vector machine with polynomial kernel with Gaussian net-based classifier with k nearest neighbor. So Gaussian net-based classifier is taking very little effort as compared to SVM with polynomial kernel. So in this case, we will always recommend to use Gaussian net-based classifier. We will not recommend to use support vector machine with polynomial kernel. Why? Because in the case of Gaussian net-based classifier and the case of support vector machine with polynomial kernel, we are getting the same model. There is no any significant difference between the model trained using the Gaussian with support vector machine with polynomial kernel. So in this case, our final conclusion we have to make like that. Okay, we will always recommend to use the Gaussian because we will also go with the time complexity. Clear?
Yes, sir. Got it, sir. Got it. Thank you, sir.
Anyone? Any other question? Yeah. So if you need this code directly, you can mail me through my mail ID. My mail ID is Lavkumar. My mail ID is Hyderabad.bits-pilani.ac.in. Okay. So if you need this code, if you need the data set directly, you will mail me. Even you can also execute this code in Google Colapse. So there is no need to install Anaconda in your system. Directly will go to the Google Colapse. That is totally open source. Directly you have to feed here all the data, whatever the data you have taken here. Directly you have to upload the data. Here you have to upload the data, and whatever the models you have generated, directly you have to run the models. There is no any problem with that. So here you can see we are going to the whatever the data is there. We are going to insert all the data, then you have to execute. It will start working for your case. Now you can see if you are going to execute, it will work for this case. So this is the models we are using. If you are going for 52 different models, it will start. It will work for all the cases. So again, and now the data is loading here. Once the data will load, it will work for all the cases. So now you can see it is working. When you are going to execute, it will work for all the cases. Now you can see it has started working. So here we are not installing any types of Anaconda in our system. Directly we are using the online tool, and it is working for all the cases. Clear? Yeah, tell me if you have any other question, please ask.
Sir, can you repeat your email ID once more?
Yeah, Lavkumar@hyderabad.bits-pilani.ac.in. I'm going to type in the chat box. Yeah. I'm going to check whether I'm getting. I have shared in the this one chat box. Just will check Lavkumar@hyderabad.bits-pilani.ac.in. So if you need any help in coding related to the Python, because we are working on totally on machine learning technique, either for the text analysis or for the normal data, normal numerical data, or we are working for the image data. In all the cases, we are working for those types of code. So if you need any help in coding, or if you need any type of code, then directly will mail me. I will share with you.
Thank you, sir, for this wonderful and informative talk.
Yeah,
We clear more of the doubt. Now I request Professor Mihir Mohanty, sir, to say some word.
Yes, thank you very much.
Yeah, thank you.
It is interesting.
Yeah. Actually, the time limit is only 1 hour 45 minutes. In 1 hour 45 minutes, if you are going to write the code, definitely it needs some time.
Obviously.
Yeah. So that is the main problem.
Very good. Actually, you have given the fundamentals. That means how to explore the codes.
Yeah, how to explore the code. Yeah. Because the theory will get from the net. If you are going to start, the theory will get from the net. But mainly how we are going to write the code,
how to implement it.
That is the main important part.
Yeah, no, that is actually very interesting topic. I have listened those things, and really it is excellent for the young researchers also.
Yeah.
They can explore with it.
Yes.
Thank you very much.
Yeah, thank you.
Associated with me.
Yeah.
Yeah. Okay. Everything is fine there, no?
Okay, thank you. So can I leave?
Yes.
Okay.
Thank you very much.
Thank you, sir.